Yes. So today we are going to learn about the terms related to probability and statistics. Okay. So let's start from very first term. Okay. Which is the random variable. So are you aware of random variables? Right?
Yes, ma'am.
Yes. So for example, this is our random variable. Okay. Means we are taking the example of dice. Wait, let me. This is the example of. Okay. Sides of dice, right? Okay, so these are the 6 sides. So this is a random variable having the set x. The second example we can take of tossing of coin. Okay, so this is an example 1. The second example we can take of what I said, tossing of coin. Yes. Right. So coins means for tossing of coins, our random variable or our set will be like only H, that is head or tail, right? So this is our for tossing of coins. Then the third one is okay, 2 examples are enough. Okay, so the first and the main term, okay, is of discrete random variable. So anyone of know what is discrete random variable? Anyone?
Yes, ma'am.
Yes, please tell me.
Discrete random variable. It has output either 1 or 0. This continuous variable, ma'am. It's the opposite of continuous random variable, ma'am.
Okay. The output of yes, okay, fine. There are two terms, discrete random variable and continuous random variable. Yes, but if taking this set, okay, if the random variable or if the yes, if the random variable I can say is from set of values, it's called discrete random variable. Okay, so if sorry if this output or if the variable is from this set, you can say it as a discrete random variable because means it can be anything from this set. Okay. So if okay, so if we move towards the probability, so probability of x is from the set as we can see we have mentioned here it is x and for second it is I can say y and the set is point Yes. And this is your random variable y. So if we want to take the probability of x, so probability of x will equals to 1. Means, for example, probability of x is equals to 1. Can you please tell me what will be the probability of x that is equals to 1 from this set, which will be 1 by 6, right? Because from 6 output 1 comes, means here if you observe 1 comes 1 by 6 times. Okay. This is same equals to if probability of x equals to 2. Okay. Same for probability of x equals to 3, because all the terms are, means probability is 1 by 6 times, right? Is it clear? If you observe here, the probability of x variable, means probability of this one present in this given set is 1 by 6, because this 6 is nothing but the total number of numbers present in that set. Okay. So if your p is even, means if you want to find probability of even number, means x is even, then your probability will equals to 1 by 2, right? Equals to probability of x equals to 2 plus okay, plus probability of x equals to 4 plus probability of x equals to 6. So your total probability will be 1 by 6 plus 1 by 6 plus 1 by 6, right? Which is nothing but 3 by 6, which is nothing but 1 by 2, as already mentioned here, right? Means you can directly say from this half of the terms are positive, means even, and half are odd, right? So the probability you can directly say it is 1 by 2, right? So this is how that 1 by 2 comes. Is it clear?
Yes, ma'am.
Fine. So same for the probability of odd. This is for probability of even. So as we know that the number of even and odd is same, so the probability of odd is also equals to 1 by 2. And same logic is also here. Just x equals to will be 1, x equals to will be 3, and x equals to will be 5. All other things will be same. It is also 1 by 6, and the logic will be same here. Okay, so this is all about the probability. Is it clear?
Yes, ma'am.
This is very basic example. Okay. So the second, okay, so the continuous random variable part remain. Okay. So height of randomly picked students, for example, if we take third example, height of randomly Pick student. Okay. So it can be, okay. We are just assuming that it can be from 120 centimeter to 190 centimeter. We are just assuming it, okay? Or you can say that it can be means less or more as well. No issue. Yes. So, for example, x equals to 162.45 or y equals to 132.62. So, if you see here, this is also a random variable, okay? So, random variable like x and y if you observed here, this comes under the category of continuous random variable, which can take any values of real number, okay, from 120 to 190. But for discrete random variable, it is only from, means it is either 1, 2, 3, 4, 5 or 6. But here you can observe it can be anything from 120 to 190. Is it clear for continuous and random? Like x and y here called as continuous random variable. Which can be or which can take any value of real number. So this was your discrete random variable, and here it is your definition of and example of continuous random variable. So so our main topic was random variable. Right? So Randy, you cleared about this random variable, discrete random variables and continuous random variable, right? This part is clear.
Yes, ma'am.
The second part we are going to see is outlier, or second definition we are going to see is outlier. Okay. So as I already explained what is outlier during the matplotlib library. Okay, still here we will see if there is any number. This is just very simple definition, okay? The list, but are the most important things in the machine learning. So what is this? If there is any number in the list, which is yes, which is odd, or we can say out of range, right? Then what is it? It is outlier. It's called as outlier. Right? For example, if you take the example of set, okay, any value that is 1.25, comma 1.45, 1.65, but by mistake it is like 18.6, 1.95. So this is your outlier, means 18.6 is your outlier. Okay, so the main means there is not particular reason for outlier. So you can see it may be manual mistakes of point. Okay, means who that person whoever feeding the data, like here it is 1.25, it is 4 point. Okay, so might have by mistakenly given this decimal point instead of after 1, he or she or that person or that machine uh, give the decimal after 8. Okay, so this is your out of range, right? Everything is after 1.1 point, means every value is very small, but 18.6 is very big range, which can harm your data, right? If you take the mean of all the things, so that mean may be vary, because every value is 1 plus 1 plus 1 will be there, and directly 18 will be there, right? So your things can vary, your data, means due to which your accuracy can vary. Okay, so it is very important to deal with outliers. One by one we will, that also we will see how to deal with outlier, or I think I have covered in any previous section, I don't know, but still I will definitely take that how to deal with outlier as well. Okay, so this is also one of the most important part in the statistics or probability. The third term we are going to take, or we are going to see, is population and sample. What is sample? What is population? I hope you people are aware of these all terms, but still there are some students who are very means this data science or this probability statistics very new to them. So I hope this section will find them, session will help them. Okay, so let's take the example of people. Okay, so set of all people in the world okay, for example, okay, so here the sign is there, yes, yes, for example, approximate value I'm taking maybe 7 billion. Okay, maybe, so for example, set of all the people in the world, this is called population. Okay, so population equals to set of all the peoples in the world, which is your main set, and your subset sample is nothing but, let me show you. Okay, so if this is better. So for example, this is your complete population or complete set. Okay, and this subset, this is called sample. For example, if you want to find the mean, okay, because if the data is if your data is too large and it is not possible to work with your large data, then you can take the sample of that data, and you can like then find its value, or you can work with that. Okay, so mu, let's take the example. If you want to annotate it, if you want to find the mean of population, then we denote it as a mu. So mu, I will use small u here. Okay. Yes. So assume this is your mu. Okay, which is nothing but your mean of the population. Okay. So actually it is not possible to write here. So I'm writing here. Okay. So for example, this is your summation of I equals to 1. Okay. And up to 7 billion. Total population is 7 billion. So up to 7 billion people. And same here as, okay. So let me clear it first. Yes. So here, as we are going to find the height, here also we can find the height. So for example, means average height for all the people. Okay, all the set means all the population. I equals to 1 up to 7 billion, and HI equals to your height. So your height means it is not possible for us, which is equals to mu. So it is not possible for us to find the average height of the 7 billion people, which is our main population set. So what we do, we can take the sample of 1000 people. Okay. And then we can do summation. Okay, so then we can do here summation of, this is, yes, then we can do summation of I equals to 1 to 1000. Okay, that we can do because it is very less value as compared to 7 billion, right? This is your HI. So this is your X bar, which is mean for the sample set. This is your population, and means mu is called as mean of population. Likewise, X bar is called as the mean of mean of sample. Yes. So let me write it here so that you will get, whenever I will share the document, you will get it. So let me write. So we can't find. Okay. So we can't find. We cannot measure approximately. Actually, this is not sign of approximately, but assume this is sign of approximation. Okay, because two tilt is not here. So approximately 7 billion. We cannot measure approximate value of 7 billion people. Okay, but we can measure its sample, right, of approximate 1000 people, right? So our X bar equals to, means we call our X bar. Okay, I don't know how to do. Okay, so assume this as a bar. Okay, so you have to write it as a X bar. X bar means like this. This is your, sorry, this is your X, and dash you have to give, so it will become your X bar. Okay, so here I don't know how to write it, so that's why I'm giving the cap. So your X bar means, you can say here, mean of sample equals to X cap Where it is? Yes, right. So the thing is, let me show you again from the diagram. Okay. Yes. So this is your, sorry, this is your population, right? Okay. So this is your population. Okay, this is your population, yes. And as I said, this is your sample set. Okay. So as the sample value increases, okay, so assume I'm increasing my sample set. So you can see that it is becoming near to your population, right? So if your sample value is here, means we mean of sample is like this. Okay. So if you are increasing your sample size, right? If you are increasing, the mean of sample will come nearly to the mean of population, right? If your sample size is less, your mean is less. If your sample size is increasing, it is coming closer to the mean of your population, right? So we can say that as the sample size increases, our x bar, sorry, or x bar is equals to mu, right? Means as your sample size is increasing, your mean for sample is becoming closer to the mu, means mean for population, right? And the most important thing is our sample is a subset of population, right? You can directly say it from that your sample is the subset of population, and population is nothing but your universal set, right? So this is what we can conclude. Yes. So this is all about the population and sample. Okay. So the thing is, in a 2 minutes meeting will end. Okay. So better I will close the session and I will start the meeting again. So please join the meeting. Okay. So that we can continue on our previous topic.
Okay, ma'am.